Today we're going to continue on my last topic, which was the wave and its characteristics. Today actually we're going to do a revision on that topic, a small revision on what are the parameters associated with the wave, and at the end we're going to do a small problem based on those parameters. So let's get on to the topic. First, let's draw a wave. So this is a wave, and now the first parameter that we need to learn on topic of wave is the wavelength. So wavelength is basically the one particle closest to the midpoint of the wave, closest to the axis of the wave. So the particle closest up here, and the next position that it becomes closest to the particle is here, and the next position is here. So the distance between once one cycle is finished, the distance between this end point and the initial point is called wavelength. So this is wavelength. In physics world, we call it lambda, the symbol, and the unit for it is meters. The SI unit. SI unit means the standard international unit. And then the next thing we need to learn on the wave is the height, the maximum height of particle that reaches on the oscillation. So the maximum height is called amplitude. This is called amplitude. Amplitude. We learned all these before, but this is just a revision. A. And the next thing we need to learn is so in order for a particle to reach, it goes one oscillation. This is just a one oscillation. So this whole thing is a one oscillation. From here to here is one oscillation, and then its second oscillation starts here. But this is another oscillation. So I hatch it differently to show you. So this is the first oscillation, and this is the second oscillation. So in order for a particle to reach just one oscillation, the time taken for it is called period. Period. Because it's a unit time, therefore we call it capital T. Capital T. So that's the time, that's the period. And the last parameter that we need to learn is the velocity. Velocity. So the wave travels this way, so it has a velocity v. So velocity v is a unit, usually a speed. It's a unit speed, which is like the time in a unit period of time, the amount of displacement of the particle. So for example, in this particular time period, the amount of oscillations, the distance that travels in particular period of time is called velocity. So velocity is v measured by meters per second. That's the SI unit. Now, there's another thing that we need to learn on this topic is the frequency. Frequency is the amount of oscillation for a period of time. So velocity is amount of the speed, the displacement or the distance of a particle particle distance. Traveling particle distance is per time, per unit time, is called velocity. The frequency, on other terms, so we don't have to confuse this, it is also a unit with unit time. So in this case, amount of oscillation, so this is just one oscillation, and then this one is the second oscillation. So if you consider this particular time, and then we have amount of oscillations for cycles per unit time. So in this case, if we say this is 2 seconds, let's say, and the amount of oscillations happen in this particular time is, this is one oscillation, this is one oscillation, and this is second oscillation. So two oscillations divided by 2 seconds. So frequency is 1. And the unit for frequency is hertz, which is oscillations per second. Which this hertz is actually from the scientists who found the unit, the frequency, by his experiment. So therefore, that's why it's called hertz. Now, the last thing we need to learn is how these parameters relate to each other. So the main formula that comes up for all these parameters relates to each other. There is a main formula for it. And before I go to the main formula, let's discuss a formula that is simpler formula, which is frequency involved equals to the inverse of the period. So period is t, so inverse of the period is 1 over t. Okay, so, or you can call t minus 1. But generally, it's better to, without confusing ourselves, it's better to do 1 or 3. Or we can cross multiply this. We call period equals the inverse of the frequency. Same thing. So that's how we relate the frequency to the period. And the main formula now is the velocity of the wave. So the velocity is equal to frequency times lambda, which is the wavelength. This is the most important formula in the topic of wave. So if we consider a small problem for this, let's say a fork is tuned at a frequency of 512 Hertz. Okay, and it also has a wavelength of 0.65 meters. For that's the wavelength, lambda is, and that's the frequency. So if we given up a problem with this, problem like this, then we can calculate the velocity of the wave is frequency, which is 512, times the wavelength is 0.65. So but important to know, these units are correct. These are the SI units. If these units are either centimeters or megahertz or kilohertz, then we need to change it back to hertz before we apply into the formula. So V equals 512 by 0.65, which is 332.8 meters per second. So that is the speed of the wave. So this is just a summarification of all the parameters that associated with wave and its characteristics. So these are things we learned before, so this is just a revision of it. So thank you for listening. Bye for now.